Hello everyone, my name is P. Viranjanaya Murali. Today my topic is orbits and types of orbits. Now we go through this. First one, what is an orbit? An orbit is the curved path that one object in space follows as it moves around another object because of its gravity. Like a smaller object which is revolve around the larger orbit because of its orbit. That path, that small body moving path is called an orbit. The orbits are illusion path. It is considered if there is a moving orbit of satellite. Basically, orbits are usually elliptical and not perfect circles, which is proposed by Kepler's first law. And we see the real examples. First one, Earth orbits the sun, the moon orbits Earth, and the artificial satellites Earth orbit. Now we see the how orbits are created. How the orbits are created. An orbit forms when an object sideways tangentially velocity is balanced by the gravitational pull of larger body. The object keeps falling towards the larger body, but because of its moving sideways fast enough, it continuously misses it. What is the forces acting on the that smaller body? First one is gravitational force. Every massive object, Earth, Sun, planets have a gravity. Gravity pulls nearby objects towards it. Examples: Earth pulls satellites towards itself forward, and satellite Earth pulls satellites like that. And second one, forward motion. Tangential velocity is another name. When an object moves sideways, like forward motion, with enough speed, it does not fall straight down. Instead, it keeping missing the surface of planets while being pulled by gravity. Third one, balance between gravity and motion. Gravity pulls the object inwards, forward motion pulls the object outwards. When these two forces balance, the object keeps moving in a curved path. This is how an orbit is created. Now we see the types of orbits. We have we have five types of orbits. First one is low Earth orbit, and second one is medium Earth orbit, and the third one geostationary orbit, and fourth one high elliptical orbits, and fifth one is geosynchronous orbits. Now we see these five orbits briefly. Here we go. The orbit path in of the different orbits. Here we have LEO, which is near to the Earth, because its radius is very small. And here we have MEO, medium Earth orbit, which is in between the LEO and GEO. And this green path is our GEO. It is the largest orbit which is currently available in space. And we have Apogee and HEO. These are the different types of orbits. Now we go through which first one, uh, LEO, Earth orbit. Lower Earth orbit is the region of speed close to the Earth, typically at altitude between 160 kilometers to 2000 kilometers above the sea level. The satellite in in this orbit circle Earth very quickly and widely used for communication, imaging research, and navigation support. Examples like human uh, space flight and research, space telescope, and Earth observation satellites, communication systems, and fifth, scientific research and satellites. These are the usages of the uh, low Earth orbits. Now we go. Now we see the features of the LEO. Altitude range is 160 to 2000 kilometers. And orbit period. The time taken to complete one orbit is nearly 90 minutes to 2 hours. And the speed of the satellite is approximately equals to 7.8 kilometers per second. And the coverage area is very small, which requires many satellites for global coverage. Signal delay very low, 20 to 40 millisecond typically. Atmospheric drags present causes a slow orbit delay. Now we go through it. Medium Earth orbits. Medium Earth orbit lies between low Earth orbit and geostationary orbit at altitudes of roughly through 2000 kilometers to 35,786 kilometers from above the Earth. It's best known as home of global navigation systems and GNNS like GPS. Examples like navigation satellites, uh, most important, and second one internet satellites, third one space research satellites, and fourth one rescue satellites. These are the applications of the medium earth orbits. And we see the features of MEO. Altitude range is approximately equals to 2000 kilometers to 35,786 kilometers. The orbit period is 2 to 12 hours. Satellite speed slower than LEO and faster than MEO. Coverage area large when compared to the LEO. Signal delay moderate. Radiation exposure higher. These are the features of MEO, and we go through geostationary Earth orbit. Geostationary Earth orbit is a circular orbit around which is around 35,786 above the equator, where the M satellites moves at the same rotational speeds as it. The key condition circular. Orbit must be circular and direct above the equator. Orbital period is 24 hours. The geostationary Earth orbit is usually used for navigation for a certain place for continuous time on 24 by 7 navigation purpose. We use the GEOs. Now we see the applications. First one is communications satellites, and second weather monitoring satellites. Third one disaster warnings and safety. Fourth one military and strategic usages. The main purpose is communication for satellite communication, normal mobile communication. We use the satellites in these orbits for disaster management, for prediction for the threats. We use the GEOs, and we see the features of the GEOs. Altitude is about the 35,786 kilometers above the earth, and the orbital period is 24 hours. The orbital shape is circular. This is the orbit. Having the orbit shape is circular, and other and the remaining all are having elliptical shape. Orbit location above the equator, which is parallelly revolving to the equator. Coverage one by one third of the Earth surface. Signal delay because of high distance from the Earth, it has a high signal delay, and these are the features of GEOs. Now we go through it. Highly elliptical orbits. Fourth one, a highly elliptical orbits. HEO is an orbit where a satellite travels in a long oval-shaped path around the Earth instead of a circle. This means one part of Earth is close to the Earth, called perigee point, and one part is very far from the Earth, is called apogee. The satellites in HEO move slowly when far away from and fast when near Earth. These highly elliptical orbits is usually developed for monitoring the orbital poles in or monitoring in poles in south and north poles. Now we see the examples: Molni satellites, Thunder orbit satellites, Arctic M satellites, early warning satellites. These are the examples for the high elliptical orbits. Now, if we see the features of the GEOs, orbit shape, elliptical and oval, closest point, perigee. Here, the the largest body is located at one foci of the elliptical path of the smaller body, a few hundreds to the few thousand kilometers, and farthest point is apogee, up to approximately 40,000 kilometers or more. Orbital period usually 12 or 24 hours. Coverage pattern, a long coverage over one region, best for high latitude areas. These are the features for sorry, uh, MEOs. Now we go through this geosynchronous orbit. Here we now see a geosynchronous orbit is an Earth orbit where satellites are orbital period equals the Earth rotation. Once sidereal day equal to approximately 23 hours 56 minutes. Because of this synchronization, I don't know, here we have this is the geos. The blue line indicates the uh, geostationary orbit, and the red line is the geosynchronous orbits. Both are circle, but geostationary orbits revolve around the equator, and geosynchronous orbits is revolving with any some inclination. Now see this, because of the synchronization, the satellite return to the same position over at the same time each day. Important. Satellite. Geostationary orbit is a special case of GSO that is circular and exactly above the equator, making a satellite appears fixed in the sky. Here the features of the GSO. Orbit period is approximately 23 hours 56 minutes, like GEO, and type typical altitude is approximately 35,786 kilometers. Orbital shape is a circular or elliptical. It's maybe both of these. Inclination can be tilted related to the equator ground tack, figure 8 pattern inclination. Here, here the orbits types GSO, MEO, and LEO. Here we have GEO, and here we have HEO. These are the overlook of the orbit, orbit and how orbits are formed and the types of orbits. And thank you for giving this opportunity. Thank you.